Okay, so this question is not in syllabus, sorry. Okay, the next one also together lah, huh? Then Ohm's law, just FYI, okay, for your information, to obey Ohm's law, right? When you plot like A, which is your current, okay, against VV, it has to cut through 0, 0, and it has to be a perfect straight line. So in this case here, this part over here will meet your Ohm's law because of this perfect straight line that cuts the 0. So over what range of voltage? So answer should be 0 to 2 volts. Okay, just for your information in case the question suddenly asks you lah, huh? Okay, next one, calculate the resistance of the filament when this much of current flows through it. So this much of current, it will be this. Then you must let it hit the graph, then goes to 1. So what's the resistance? So V equals to Ri. Okay, R is the unknown. So 1 equals to R 0.25. So R will be 1 divided by 0.25. Let me press calculator. Where's my calculator? Okay, so 1 divided by 0.25 equals to 4 ohms. Okay, so if the filament has been made with the same wire but using half the length, so the thickness is the same, so now I'm only using half the length. So what will be the resistance? So the resistance will drop, right, because lower length ma. Okay, so resistance will drop. So what will be the resistance when this much of current flows through it? So R equals to rho L over A, remember? So this is the same. This is the same. So when L reduces, R also reduces. So they ask you what's the resistance. So resistance should drop. So if resistance drops, what happens? You realize they are using the same current, so they're trying to link it up. Okay, so resistance over here is this much, right? You drop by half the length, right? So the resistance should be 2. You halve it, right? Half the length, you halve it lah. Okay, next, this one over here, it says that it has 3 resistors, 3 ohm, 4 ohm, 12 ohm. Okay, so which two ammeter shows the same reading? Okay, so over here, let's put it this way, so you must always make sure you know how it flows. Okay, then it will start to split, then it will start to split this way. Okay, so which two ammeter will show the same reading, the same path, of course, same reading lah. So M equal A1 and A2, sorry, A4. So what is the effective resistance? So this part over here is parallel, so that's where I have to do first because it has more. Then later on I will add to this one, which is actually in series to the parallel. Oops, series. Okay, so I must plus the parallel first. So 1 over 4 plus 1 over 12, whole thing invert. I plus my 3 ohm. Okay, so 4, 8, 12, 3, 4 over 12, invert 12 over 4, 12 over 4, so it's 3 plus 3. This gives me 6 ohm. Okay, you press your calculator, you should get the same answer as me. Find the ammeter reading for A1. So I want to find out what is A1's answer. So to find A1, A1 is in the main. This is the main current. Okay, so main current means I need to find total current lah. So total current, total voltage, total effective resistance, I find my current. So I will be equals to 12 over 6. This gives me 2 ampere. Okay, next, show a circuit. So before I start doing, I make sure I color first to know how it works, how the current flow is always like that. Okay, then they ask you effective resistance of 6 and 12 only. 6 and 12 are in parallel, right? So I will just add. So 1 over 6 plus 1 over 12. Don't forget to invert it. 6, 12. So 3 over 12. 12 over 3. This gives me 4. They wanted total resistance in the whole circuit. So I must plus the series, which is this one. So I must do this one first, then plus this. I will get the total resistance. So plus 2. So plus 2, I get 6 ohm. So what is the current flowing through the 2 ohm? Where is 2 ohm? 2 ohm is here. It's in my main. Okay, let's use a different color. Main circuit current. This is my main current. So to get main current means I must use total V. I must use total, oopsie, total R, total I. This is my main current, means it's total I lah. So everything must be total. So V is what? V is 24. So V equals to Ri 24. I got my R, which is 6. So I equals to 6 shall 18 therefore 4 ampere. Okay, so what's the potential difference across 6 ohm? So I know this is 4 ampere already. Okay, I want to know the potential difference across 6 ohm. So over here, how will it split? So I must ask myself, okay, this is 4 ampere, this will also be 4 ampere. So how will it split when it reaches here? The one that has a lesser resistance will have more current. The one that has more resistance will have less current. So the ratio is 1:2. Make sense? So if it's 1:2, I will need to split accordingly. So 1:2. Okay, another way before I move on, this is a bit tough, right? So the easier way will be, you see, they said that the resistance across a parallel circuit is 4 ohm. So that means over here, this is 4 ohm and this is 2 ohm, right? Okay, if you cut it like that, So what does it mean? So this 24, right, you can go by ratio. Okay, how do I go by ratio? I must know that, very simple. There's more than one way to roam. Okay, so in this case here, must always remember when V go up, R will also has to go up. So over here, my ratio is 2:1, right? So if 2:1, if I have 24 volts, it's actually 3 units because total units 2:1 so 2 plus 1. So 1 unit is what? 3, 6, 9, 12, 15, 18, 21, 24, 8 volts. Oopsie. 8 volts. So that means to say that this will get 8 volts. This one will get 8, 16 volt. Add together, I get 24 volt, which is total. So potential difference across a parallel circuit is always the same. So over here is 16 volts. Over here also has to be 16 volts. So this is in fact an easier method as compared to using my current. I split like that. Then I use the resistance multiply. It's a bit tougher. So this is the easier method. So the answer should be 16 volts. Oops. 16 volts. So what's the current? That is where you use V equals to Ri to help you, which is easier. So I get 16. My R is 6. I will be, because if I have done by the current method here, I will be able to do it first. Then it looks a bit funny because the question is asked later. Okay, so 16 divided by 6. Okay, it's a weird number, so I have to bring it to 3SF, like that. Okay, so that's the reason why if I use ratio method, it'll be easier to find potential difference rather than go and get it from the resistance side. Okay, all right, that's it. Thank you.